Algorithmia helps our customers move from machine learning development to deployment. Some of the mechanisms in Algorithmia that are used for this purpose include audit trails and logs of model activity. To demonstrate this functionality, let's assume that I'm a manager on the DevOps team with a tight compliance deadline. Someone provided me with a timestamp from a few months ago and asked me to prove that the model that we were using was loading the correct image data at that time. This particular algorithm uses a deep learning model and GPU resources to determine whether a satellite image contains an aircraft or not. It loads in a trained model and image data using the data connectors and data APIs in Algorithmia. The model takes in a path to an image, and then the algorithm returns a predicted value of 1 if the image contains an aircraft, and a value of 0 if the image does not contain an aircraft. Let's check the usage report in the administrator dashboard to see which versions of this model were called recently. Here we can filter the usage by algorithm, and in the list below, we can see that a few different versions of this aircraft detection model have been called. Using the timestamp information that I was given, let's drill down into the audit logs and determine the specific version of the model that was called at that time. We can then use this information to track down the image dataset that was also used at that exact time. We can access all of the logs in Algorithmia from the administrator dashboard. Algorithmia tracks the activity across all models, including which user and API key requested a model in a particular organization. We'll include all of the audit logs here, then expand the time range to include the time period when the model was actually called. After applying that new range, we can search for the timestamp to review all of the activity that occurred at that specific time. Here's a list of all of the events that occurred, so now we can take a deeper look. This particular log record shows all of the detailed information, including the user that called the model inputs and outputs, the version of the model that was used, version 3, and the corresponding commit hash from version control, which starts with 4BF1. We can use this information to track down the version of the image dataset that was used when this model was called. Now, if I navigate back to the landing page for this particular aircraft detection algorithm, there are a couple of places where I can check the version and commit history. First, I'll check the version history. I can see that version 3 of this model has some information in the release notes about using S3 as the data source. Second, I can navigate to the list of builds for this algorithm. Here I can see that the commit hash matches up with version 3 of this model that was published earlier. I can also click on this particular version to see detailed information from when it was built. Because every algorithm is backed by a Git repository and version control, I can inspect the source code history to determine the data path that was used in the older version of this model. If I view the commit history, then I can see the commit hash for version 4BF1 here. Then I can inspect the source code for the algorithm. In the source code, I can see a reference to the model files and the image data set that are stored in S3, and this data is being accessed using the data APIs in Algorithmia. Finally, if I navigate to the Data Sources tab in Algorithmia, I can see that there is a data connector for S3. This data source is restricted to the S3 bucket called Algorithmia SE. Now that I know the name of the S3 bucket and the path to the image dataset, I can forward this information to a forensic accountant to track down the provenance of the data that resides in that particular storage location. In summary, Algorithmia helps teams work together and mitigate compliance issues in production by using audit trails and logs of all model activity. Algorithmia automatically handles the deployment, operation, and security of my models.